everyone, my name is Meggan Dingus, and I'm a third-year school psychology graduate student, and I'm very excited to be presenting at the Graduate Research Forum for Miami University. My thesis advisor is Dr. Sarah Watt, and today what I'll be presenting on is my thesis project of Keep Changing How to Teach and Flip Our Thinking of Fractions. The National Council of Teachers of Mathematics regards fractions as the most important foundational mathematical skill developed, yet fractions are one of the most difficult skills for students to master because of a lack of conceptual knowledge of fractions. When you think about mathematical proficiency, you want students to understand the concept behind what they're doing. And the NCTM have pushed teachers to promote this by helping students develop habits of mind through a variety of pedagogical or teaching approaches. The purpose of my current study will be to examine how visual representations of fractions impact student learning outcomes. We'll be looking at the procedural versus conceptual learning outcomes, evaluating the impact of visual models for fractions in gifted and general education classrooms, as well as understanding if there is a relationship present between correct visual models and correct problems overall. Now, thinking about my literature review, there are some important concepts to understand before moving forward. So, when I talk about conceptual versus procedural, what I'm really talking about are two different approaches to math. Now, conceptual is understanding what's going on behind what you're doing in the problem. It is understanding the concept of what you're doing. And there is a strong correlation between conceptual teaching and techniques and higher student performance on post-test and follow-up assessments, even weeks and months later. Now, procedural is how I was taught math, and it was you add A plus B to get C. It is really only understanding the procedural process of how to do math. And learning with this approach increases the likelihood of both conceptual-based and procedural-based errors. When I say that, procedural-based errors are the common errors you have when you're supposed to add instead of subtract, or when you forget to carry a 1. Those errors, even the most talented mathematicians make them. However, conceptual-based errors are those errors where you are doing the problem wrong because you don't understand what you're supposed to be doing, or you don't understand why you're supposed to be doing a certain thing. And so, in order to decrease those conceptual-based errors, it's important for students to understand the concepts of what they're doing in math. Now, when you think about conceptual and procedural, it's hard to imagine how you can build conceptual concepts, or at least it was for me when I was thinking about math, because I'd only been taught with a procedural approach. Now, this is an approach that really combines the two and provides a link that is used in a lot of instructional methods, and this is called the Concrete Representational Abstract Sequence, or the CRA Sequence. Now, when you look at this, concrete is using physical manipulatives. It helps with conceptual understanding and learning, and it's adding those two blocks and stacking the one block on top of it for students to understand that 2 plus 1 equals 3. And once students master that, they're able to move on to the representational, which is using pictures. You're able to draw the problem using 1 square plus 2 squares equals 3 squares. And it's still providing that scaffolding without the students having to have a physical manipulative. And the representational are those visual representations. And this representational aspect provides a link between conceptual and procedural learning. And as you see, it's in the middle of this sequence. Abstract is when you use equations. It only uses numbers. The procedural problems are how math is traditionally taught, and that's when you understand 2 plus 1 equals 3, using those symbols. Now keep in mind, the sequence can be used in any order, from C to R to A, or from A to R to C. And it's used in that way so that students say they're struggling and you add 2-digit addition. You can take them back to that representational or that concrete piece, and you can say, okay, let's understand the concepts behind it, and then move back up to the abstract. So it's a sequence that provides scaffolding within itself to allow students to understand the problem in multiple ways. Now, the gaps that are present in current literature are that all studies that link the CRA sequence to student outcomes use the CRA sequence as an added intervention instruction, rather than a pedagogical approach to teaching. And students that are evaluated in previous studies were currently struggling in math or had a identified specific learning disability in math. CRA effects were not evaluated in general education or gifted education classrooms. Every piece of literature, though, addressing conceptual learning of mathematics called for a need to review conceptual learning instruction in relation to all students. And that's where my study comes in. The research questions I was aiming to address were: what is the relationship between the student's accuracy of visual representations and multiplying and dividing fraction problems? As well as what associations exist between the type of learner and the immediate student learning outcomes. And my last question was: what associations exist between the type of instruction and immediate student learning outcomes? Now, the methods I used for this study were: the participants were a sample of around 114 sixth grade students, ages 11 to 13. 37 of them were gifted education students, and 77 of the students were in an inclusive general education classroom. Now, the school was selected through a university partnership, so that is how we gained the participants for this study. When we were testing the students and gathering data, we did this in a twofold approach. So we gave students a pre-test and post-test that looked exactly like this. This was the exact pre-test we gave students that provided the procedural piece of problems on the left-hand side, where you see those just general abstract or equation-based problems. And then we were able to evaluate that conceptual piece by giving students a word problem, and then they had to draw visual representations of that word problem, and then also link that with an equation and give us an answer. What we were really focusing on is, can the students accurately give us a visual representation? And what we found is that students in gifted education were able to give us the equations really easily. And students in general education struggled with this. However, both groups of students really struggled with that visual representation piece, both on the pre-test and post-test, although there was improvement that I'll get into more. Now, when we did this, we also videotaped teachers teaching these concepts, and we did that to ensure fidelity in our study and show, are there differences in how the teachers were teaching? Now, the results were, we first used a ANCOVA, and we compared post-test total scores between groups, and we used the pre-test procedural as the covariate. So we used this left-hand side just as our covariate, because if students were able to perform well on this in the beginning, we assumed they would perform well on it at the end. And we didn't want that to impact students and our results. We wanted to show growth. We didn't care how they performed at the beginning. We wanted to see how they grew. Now, what we found is that students' total scores between groups increased, and they were significant, both in the p-value and the f-value, which was really cool to see, is that students, their total scores increased, which is great. Like, that shows that there was great teaching done. Now, when we look at their post-test visual representation scores between groups, still using that pre-test procedural as the covariate, we found that there wasn't a significance between the two groups. What that means is that students, when you compared the two groups, you were able to see that the students were performing the same. And let me rephrase what I said before, because I don't think I said it correctly. When you looked at the total score, there was a difference. Gifted students were outperforming their general education peers. But when you looked at those visual representations, they were not outperforming their general education peers. They were actually performing pretty similarly. What that shows us is that these students were all gaining these visual representation skills that they did not previously have. Although some students really did a good job drawing some visual representations, they were not accurate depictions. We also looked at the correlation, and we looked at the relationship between those post-test visual representation scores and the post-test equation. And what we found is that there is a positive relationship. Although it is weak, it's still significant, showing that students that performed better on their visual representation scores performed better on just the equation piece as well. So obviously their overall score was better because they performed on those visual representations, but we compared it with just the equation piece, and they performed better on their equations when they understood the visual representations. And when we looked at that fidelity data of were the teachers teaching different, we actually found that there was no significance. So that gives our study a lot of power to say that the students, their scores were similar because they were in similar teaching environments, and we're able to compare them in that way. Even though that they're gifted versus inclusive learners, there is an ability to compare them because there was no difference in their instruction. Now, when we look at our research questions, the first one, there is a positive relationship between a student's accuracy of visual representations and their ability to perform procedural problems, both with gifted education learners and general education learners. Now, we did see that there's no associations exist between the type of learner and the immediate student learning outcomes when we're thinking about those visual representations. Now, we also see that there are no associations between the different types of instructions and the immediate student learning outcomes. Now, there are some limitations to this study. There was the absence of maintenance data. We were not able to go back in a month or so to retest the students. There just wasn't the ability to do that at this school. And I hope that in future studies that they really can get this maintenance data, because it would have been wonderful to see. We also had a limited sample size. Although we had over 100 students, we only used one school that used the same curriculum, regardless of their ability level of their students. So it would have been great to have had a larger sample size at multiple schools. Also, sometimes the quality of the video recordings impacted our blind coders to be able to code the videos accurately. And if I did this again, I would have better video recording quality. The implications of this research, though, demonstrate that there is a significant relationship between the success in procedural problems and visual representations, and that although students in gifted outperformed their peers on overall post-test scores and procedural scores, they are performing similar to their peers on visual representations for their post-test. So it's showing us that students, although they're outperforming overall, they're still not understanding the concepts, even if they are gifted learners. And we also did do an ANOVA as well as an ANCOVA, and we found that the study shows the same results of significance. So even without having that controlled variable, there was still significance of the same amount. And if anyone has any questions, I would love to answer them about my study. I'm really passionate about this topic, and thank you for listening. My email is at the bottom right there, and I would love to hear if you have any questions. And there are my references just so that you have them if you want to look at anything else. And thank you. Have a great night.